Okay, last time, you guys just really quickly, last time in class we learned some of these, we learned these identities, most of them you know already, but we're going to just review them really quickly. First of all, the reciprocal identities, secant equals 1 over cosine, and that one also, if you solve it for cosine, would be cosine equals 1 over secant. Cosecant equals 1 over sine, and if you solve that one for sine, it's sine equals 1 over cosecant. And then the bottom one right here, cotangent of theta equals 1 over tangent of theta. And if you solve that one for tangent, it's tangent theta equals 1 over cotangent of theta. Those were the reciprocal identities. Remember those last time? We're going to be using those a lot. Okay, then we learned the quotient identities. We learned tangent of theta equals sine over cosine. Cotangent of theta equals cosine over sine. So we got those? Remember those? You guys all have them written down, so I'm not going to spend any time on them. And then we learned the Pythagorean identities. The three on the left are the three main ones. You need to know those really well. But if you solve for a different, on this one you can solve for cosine or sine, and you get those two different identities. And then 1 plus cotangent squared of theta, you can solve it for cotangent squared or for 1 and get those two different identities. And then the bottom one, you can get those two different identities, okay? I'm doing this mostly for the people who weren't here last time, you guys, so. But you guys should have all those written down. Remember those identities. Okay, we're going to have to memorize them. That's your goal. Okay, and we learned how to use them. I'm going to skip a lot of these slides right here. We did all these slides. We simplified them last time. So you learned how to do that. I think we got to, right, we did this one, didn't we? I think this is the one we got to. Let's, wait, one more, isn't it? Okay, we didn't do this one here last time. Let's see if you can do it. Get our piece of paper. You're going to be in here, Krista. You're going to learn. Okay. See if you can do this one. I know you guys weren't expecting to learn on the last day of the quarter, but I'm not cramming. This is for next quarter. It's not. I disagree with that totally. Well, no, seriously, if you've seen it once before, and then when we come back from break, it'll be easier to remember it and learn it. You want me to start from the start today? I don't think you want me to start from the start today. Okay. Who thinks they know what to do on this one? I'll give you a hint. I would use the quotient identity for one of those. Which one? The cotangent, right? What could I rewrite that one as? Okay, so I can write the cotangent as cosine squared of x over sine squared of x. Remember, cotangent squared means cotangent times cotangent, and then each one of those is going to be a cosine over sine, which if you combine those, it's cosine squared over sine squared. Okay, and we're just simplifying this. So, do you see anything we can do right here? Yeah, we can cancel out some sines. Well, how many sines are on the bottom? Well, it's sine squared, right? That means sine times sine. So one of the sines cancels out. I'm just going to cancel out the squared with one of those, with that sign right there. Can't cancel with this sign because that sign's being added to it, right? So now we have sine of x times cosine squared of x over sine of x. Whoops, that should be a plus. You're right. Because it's this sign that we brought down, and we had that plus sign right there, okay? So we talked about this last time. What's something we can do right here? Common denominator. Yeah, we got to use some algebraic manipulations. Jericho, were you going to say something? Were you going to say common denominator? Why did I get sine squared down here? Because cotangent is squared. Cotangent squared means cotangent times cotangent. And then each of those cotangents is a cosine over a sine, right? Cosine over a sine. And then if you want to combine them, cosine times cosine is cosine squared, and sine times sine is sine squared. And that's why I had sine squared right here. Is because cotangent squared is equal to cosine squared over sine squared. It's not, the quotient identity is one of the identities. It just didn't have a square in it. But like I showed you right here, we can rewrite it as cotangent times cotangent, and we know cotangents can be written as cosine over sine, right? Tangent squared, well, tangent is sine over cosine. Is that what you're asking? The definition of cotangent is, on the unit circle, is x over y, and x is the cosine and y is the sine. So it's cosine over sine. Yep, cotangent's x over y. Cosecant is defined to be 1 over y. So it would be 1 over sine. That's our reciprocal identity. Okay? Were you not here last time? Okay. All right, let's finish this one. Okay, Sean mentioned that we need to get a common denominator to add these together. Right now, that one has a denominator 1, and we have a sine as a denominator here. So what is the common denominator, you guys? Sine, right? Sine of x. Okay, and we changed the denominator of the one on the left. What did we change it from 1 to sine? So we timesed 1 by sine. Put that away, you guys. We're doing class right now, okay? 1 over sine. 1 became sine. So what are we going to do to the top? Sine squared, right? And cosine squared. Okay. We had to get common denominators. Do you understand how we got common denominators? If you just take the two denominators times together, that's your common denominator. 1 times sine is sine, right? So this one right here, it already had a denominator sine, so the numerator didn't change. But the one on the left, its denominator was 1, and we times it by sine to get it, right? So we had to times the top by sine as well, sine squared. Okay, Jerica. Okay, you got it? Now, since we have a common denominator, we can write it as 1. We can write this as 1 fraction, you guys, and with a denominator of sine of x. And the top we can write as sine squared of x plus cosine squared of x. Do you recognize any substitutions we can make right here? 1 for what? For the top. Why can we substitute 1 for the top? Yeah, it's one of our Pythagorean identities. Sine squared of x plus cosine squared of x is equal to 1, right? So we can make that substitution. What is 1 over sine of x? Cosecant of x. Yep, you just asked about that one. That's the reciprocal identity for cosecant. Nope. Probably not this one. There's some of them there's fast ways and slow ways, but this one is, I think we pretty much done. I could have skipped some of those steps because this right here I could have just written as 1 over sine of x. I could have skipped right in this step right here, but when we take the test on this stuff, the final answer is not what I'm looking for. What I'm looking for is all the process. So your process is your answer on the test. So you need to be able to process that right now. Got it? Okay. So I told you that was. Does it seem hard or not? Well, it just depends. Everybody learns different things differently. So this might be easier for you, where some of the other stuff was harder for you. But just from past classes, I've been teaching this class for 20-something years. I just know that this is usually where students struggle the most. We're doing it the first of fourth quarter, so you get a chance to recover your grade if you don't do so well, but I would suggest doing really well on this right now. Okay, if secant of x is equal to 3/2, find cosine of x. Now, when some of you guys looked at your homework assignment, you saw that stuff on there, you want to know how to do it. We are going to learn how to do some of that stuff right now. This thing says, if secant of x equals 3/2, find cosine of x. Now, how can I find a cosine if I know a secant? Using identities. What was that? There is a relationship. What is that relationship? The reciprocal identity. So what does the reciprocal identity say? Yeah, it says secant equals 1 over cosine, but we want cosine to be by itself on one side because we want to know what cosine is. So is there another way we can write it? Cosine equals 1 over secant. Because since cosine's what we want, we're going to want to get the identity that has cosine by itself. Then what can we do right here, Sean? Well, it says secant is 3/2. So we can make that substitution, couldn't we? I know what you're thinking. You're on the right track. You're just a step ahead. What? Well, secant of x is equal to 3/2, so we can replace this secant right here with 3/2. So we have cosine of x equals 1 over 3/2, because secant is equal to 3/2, right? If two things are equal, can you substitute them for each other? Secant is equal to 3/2, so can I replace this secant with 3/2? Okay. It's hard at first. Anything you learn at first is going to be hard. As you study it and think about it, it's going to get easier, I promise you. But you got to actually study it and think about it. Okay. This is what you were talking about, Sean. 1 divided by 3/2. What is that? Yeah. So what is the reciprocal of 3/2 is 2/3 times 1 is 2/3. So there you go. There's your answer. Want to know what the cosine is? There it is. Yeah, right now we can just say this. We already know cosine and secant are reciprocal functions, so we could have just said, hey, if you flip that over, that's the answer, and that's what Sean was saying. But I was just showing you make some substitutions because I wanted you to see the substitution because there are some problems we're going to need to use that. Okay, here we go. Next one. If cosecant of x equals 4/3, find the tangent of x. Now, you got to look through your identities. Everybody get your identity notes out and think, okay, which identity has a cosecant and a tangent in it? When you think you know, raise your hand. Which identity has a cosecant and a tangent? Andrew's got it. Anybody else? Okay, Sean's got it. I think there's only one. Well, there's a couple versions of it. Which one is it? Yep, the Pythagorean identity. What does it say? Does it say cotangent squared or cosec? But you said cotangent, and this is a cosecant. What's the identity with a cosecant and a tangent in it? Is there one? Oh, there's not one, is there? Okay, I'll tell you what we can do. We can just do what we did last time. Cosecant is the reciprocal of what? Of the sine. Okay, so cosecant's the reciprocal of the sine. So what would be the sine, you guys? 3/4. Got that? Well, no, what we're going to do now is use the Pythagorean identity that has, because we know tangent, you can get tangent if you know the sine and cosine, right? We got to find the cosine. Yep, Pythagorean identity, first one. Sine squared of x plus cosine squared of x equals 1. If I make the substitution right here,
teachers, if there are any ballots that have not been turned in, please go turn them in to the workroom on the second floor. Okay, everybody will be there and turn them in, please. Thank you.
okay, so we make that substitution, and 3/4 squared is 9/16, right? Plus cosine squared of x equals 1. We got to solve that for cosine. How do you solve that for cosine? Huh? Because if we know sine and cosine, we can find the tangent because of the quotient identity, right? So we solve for x. We got to solve for cosine of x. So we're going to minus 9/16 from both sides. If I minus 9/16 from both sides, I'm going to get cosine squared of x equals 1 minus 9/16. What's 1 minus 9/16? One minus 9/16. It's what? 7/16. And then I take the square root of both sides. What's that? By the way, we don't know, the square root of 7 is not a perfect square, but the square root of 16 is 4, right? So there it is. It's actually plus or minus the square root of 7 over 4 because we took the square root of both sides to get we had to take the square root of both sides of this, and so we're going to get a plus or minus. Okay, now we know what sine is, we know what cosine is, we can find the tangent now. How do we find the tangent? Tangent is equal to sine over cosine, right? Sine is 3/4. Cosine is plus or minus square root of 7 over 4. We'll just put a plus or minus on the answer at the end. You guys are all looking dead. Yeah, just to divide, remember you times the top one, so it's going to be, well, let's just write equals this right here. 3/4 times 4 over the square root of 7. What happens here? 4's cancel out, and you get 3 over the square root of 7. But what do we have to do to the square root? Can't be on the bottom, so we times the top and bottom by square root of 7. What would we get? 3 square root of 7 over 7, right? And it's plus or minus. So that's your answer right there. Plus or minus 3 square root of 7 over 7. Kind of complicated. Good job, Lauren. Lauren's on a high biorhythm today, man. I think. What we did from there is we had 3 over the square root of 7. And you remember, mathematicians don't like radicals in the denominator. So we have to rationalize the denominator by timesing the top and bottom by the square root of 7. Do you remember that? 3 times the square root of 7 is square root of 7. And square root of 7 times square root of 7 is 7. Remember that? That's how we got that. And we had to do the plus and minus. Okay? All right, now. Is that it? If cosine of x equals 3/4, find secant of x. That one should be an easy one. Raise your hand when you got the answer. What is it, Lydia? 4/3. Why? Okay, they're reciprocal identities. Remember, the secant of x is equal to 1 over the cosine, right? So the secant of x is equal to 1 over 3/4. So the secant of x is equal to 4/3. But all you have to know is that secant and cosine are reciprocal functions, and so you just flip it over, 4/3. Okay? Can I go back? Yeah. I have 2 more slides to show you, and then I'm going to give you the homework assignment. I mean, then I already gave you the homework assignment last time, but was anybody not here last time? Oh, yeah, Ramon, you weren't here. Sorry, are you catching on to this a little bit? Yep. That's what I like to hear. He is a genius, but it's partly because he studies, too. It helps when you study a lot. What? Ramon, come on. You know, I have to say, some of you guys are naturals at math, and it's your thing. And some of you guys are just math comes easy to you. And some of you have to, it's like playing a sport. Some of you guys are good at sports. Some of you aren't as good. Some of you are good at art, and some of you are not. Everybody has their things that they're good at, right? So if we have something that you're not as good at, you have to work a little bit harder. I hate to tell you guys that, but if you're not a natural at math, you got to work a little bit harder. I was like that. I wasn't as smart as Ramon and Sadie and some of you guys. Sadie's a genius. She keeps telling me she's not. But then I said it's because she studies, and she says she doesn't study, so. Yeah. Okay, here we go. Next one. Okay, this one right here. Is there an identity that has a cosine and a cosecant in it? But we can use the what? Yes, we can. Good job, Sean. Sean noticed that we can use that first Pythagorean identity and substitute 3/5 in for cosine, right? How is that going to help us? How is that going to help us? Well, it gives us what? What are we going to be able to find if we solve this? Sine. And how does a sine relate to a cosecant? It's a reciprocal. So if we can find the sine, we've got the cosecant, right? Is that what you saw from the start, Sean? Almost. Sounds like you got it down. Minus 9/25 from both sides. What do you get? What's 1 minus 9/25, you guys? 16/25, right? If I subtract 9/25 from both sides, I get 16/25. See, I skipped a step right there. Did that foul some of you up? You back on track? Okay. Then what am I going to do? Square root both sides, and you get sine x equals plus or minus what? 4/5, because both those are perfect squares. Square root of 16 is 4, the square root of 25 is 5. So now, I know sine of x. Do I know cosecant? No. 5/4. Plus or minus 5/4. Whoops. You had to use plus or minus because that's what we had down here. Plus or minus 5/4. We got it? Last slide. Here's 2 more identities you need to know. Sometimes these are called even odd identities. Some of people call it opposite angles identities. That's what your book calls it. Sine of a negative angle is equal to the negative sine of the angle. And cosine of a negative angle is equal to the cosine of the angle. I could show you on the unit circle chart. Look right here. Look at a sine. Let's say a sine of a negative angle. Let's go like sine of negative 11 pi over. Sine of negative pi 6 would be right here, right? What is the sine of negative pi 6? It's negative 1/2, right? Well, we could have gotten that just by going to sine of pi 6, which is 1/2, and making it negative, right? And that's what that's saying.
No, I got that one.
Cosine. Well, cosine, you could go like this. The cosine of a negative, let's say, okay, a negative pi 6. Cosine of negative pi 6 is square root of 3 over 2, right? And the cosine of pi over 6 is a positive square root of 3 over 2. They're both positive because you went to the right both times. Got it? And these are called opposite angle identities. And you might see something in there. It might say something like, say the cosine of negative 45 degrees. And you're going to say that's equal to what? Cosine of, using that identity, what would you say? 45 degrees. Okay, 1. Yep. 25? Okay, number 25 on the assignment. What does it say? Does it say find cosecant of theta? Okay, what are the directions? Let me see. Can I read it? Number 25. Use the given information to determine the exact trigonometric value. Okay, sine of theta equals 2/5, and theta is between 0 and 90, and cosecant is what we're looking for. Okay, so here's my hint. Sine is 2/5, right? Sine of theta is 2/5, and it tells me theta is an angle between 0 and 90 degrees. Which quadrant is that in, you guys? Yeah, all this is doing is identifying the quadrant. Which quadrant? Okay. And it's the first quadrant. And so I want, and we know that sine and cosecant are what? Reciprocals. So what is the cosecant? 5/2. And the reason they had to identify the quadrant is so we know if this is positive or negative. Well, we know that everything's positive in the first quadrant, right? But cosecant's associated with a sine, and a sine is the y-coordinate, and y-coordinates are positive in both the first and second quadrant, but negative in the third and fourth. So if it would have been in the third or fourth quadrant, then our answer would have been negative. Okay? So that's why we had that. Does that help you out? A lot of those problems after 25 you're going to have to use Pythagorean identities for. Okay? All right, that concludes today's lesson. I'll just go one at a time. Okay, here, for those of you who were not here last time, that is the assignment. I'm turning it off, so pause it if you're at home.